Okay, so let's look at what we do not know. We do not know the rate at which the bacteria are growing. What do we know? We know that we started out with 75 and 4 hours later we had 200. So the way the formula works, P e to the RT, P is always your starting number. T is time, so it's 4 hours. So we started out with 75, end up at 4 hours later, and then we set that equal to how many we ended up with. So we're going to do a calculation to figure out what the rate is because we need to know the rate to answer the actual question being asked. So this is a two-part solution process. First, use the first piece of information to figure out what the rate is. So let's figure out the rate. I'm going to do the algebra here. Okay, and we're going to get E. And I'm going to, instead of writing R times 4, I'm going to write 4R. You can keep it as 4 times R if you want, but I like having the variable after the number. All right, 200 divided by 75, that simplifies to 8/3. That's not a nice decimal, so leave it as a fraction, all right? And now what do we have to do? We need to natural log both sides. That gets rid of the E. We end up with 4R equals the natural log of 8/3 divided by 4. And R equals, and I already did this calculation, 0.2452. You want to go out at least 4 decimal places. Do not overround your rate. Okay, so we have the rate. Now look what we have to do. We have to use the rate to calculate the actual question being asked. The question is, if we start out at 75 bacteria, how many will we have after 24 hours? So our start number is still 75. And we still have E. And now we know R is 0.2452. And we know T is 24 hours, right? And we just need to do that calculation. Is everybody clear why we switched to 24 hours? Okay, because that's the question was, if you start out with 75, well, how many you have after 24 hours? So we're using the rate from part 1. You just type that straight into the calculator. You end up with 26,965. I'm going to round to the nearest whole bacteria. So that's quite a bit of growth.